All right, with less than 10.3c, which is the last of 10.3, we get into what we call complex conjugates. So far, we've seen basic operations where we're supposed to take this thing here, recognize that this is 9 times 3, which would be then become a 3 times 2, so 4 root 3 minus 6 root 3, which then makes negative 2 root 3. Again, that was section 4, 3.1a. We also learned to multiply, which then makes this 15 root 12 minus 5 root 4. Understanding root 12 is 4 times 3 means that's a 2, so 30 root 3 minus that's a 2, which makes 10. Again, those things should be more natural for you now at this point. And then last lesson we just saw kind of introduced doing this, where you do this times that, which would be 6 root 9 minus 9 root 15 plus 4 root 15 minus 6 root 25. That's a 3, which means that 6 root 9 is 18. These don't simplify. 4, 9, 25 does not go, so I'm just going to put those together to make minus 5 root 15. And then I'm going to say this root 25 is 5 times 6, which makes 30. Those two put together makes negative 12 minus 5 root 15. So again, all that's been covered, all that's been talked about. Keep in mind, yesterday we were introduced to the process of rationalizing denominators. In that, remember, we were supposed to say we can't have a radical on the bottom, and so we put root 6 and root 6. With that being done, we do 3 root 6 over 6, because remember that's the case. And then remember also that you have to simplify any outside numbers. 3 and 6 can both divide by 3, so it's just root 6 over 2. We also learned that we were supposed to split this radical, then multiply to get rid of whatever is on the bottom. 25 times 7, 7 quarters, I believe, is $1.75. And since that is quarters, it means that 25 definitely goes into it. That would be 5 root 7 over 7. So again, these are all things you should know at this point, and if you don't know them, it is your job to make sure you speak up before that test pops up. Today what we're going to do is look at the highest level of rationalized denominators, which is called the complex conjugate. The reason this is important is because it's not just a radical or a number being multiplied. If this was 2 root 3, I would just multiply by root 3 and that's fine. This is root 3 plus 4. So what we have to do now is multiply by the conjugate that we talked about a couple of lessons ago, which is root 3 minus 4. In the end, you have to distribute this 2 to both, so it's 2 root 3 minus 8 over, and I usually don't do the work here, I usually do it underneath. This will be root 3 times root 3, which is 3. Root 3 times negative root 4, which is negative 4 root 3. 4 times root 3, which is positive 4 root 3. And then 4 times root 4, or 4 times negative 4, which is negative 4. Notice how these two things cancel, giving us negative 1. And that's what goes on the bottom. But of course, you don't want to leave a negative 1 on the bottom, so that means we have to switch all three things. So this actually turns into negative 2 root 3 plus 8, because you switch it, all over 1. But again, we don't need to put it over 1. That would be your answer. But again, the trick here is whenever you see a root plus a number, not times a number, but plus a number, you have to make sure that you actually use the conjugate to get rid of it. 2 more examples before we get ready to get to work. Here, again, the root 10 is breaking it, but it's root 10 minus 8, so we need to multiply by root 10 plus 8 on top and bottom. Multiplying that, you get 6 root 10 plus 48, because you got to remember to multiply by both. Remember, we're going to do the work here underneath, though. Root 10 times root 10 is 10. That would be 8 root 10 minus 8 root 10 minus 64. These two things cancel, which is why we use the conjugate. 10 minus 64 is negative 54. So what does that mean? Let's look at all of our outside numbers. 6, 54, and 48, I believe, are all divisible by 6. So I'll turn that into root 10, because that's divided by 6, plus 8, because 8 times 6 is 48, over negative 9, because 9 times, again, divided by 6, all those break down. Now remember that we don't want to have a negative on the bottom, so we end up with negative root 10 minus 8 over 9, because you can't have a radical on the bottom. You also cannot have a negative number on the bottom of a fraction. So just keep that in mind as you go. Yes, it's a lot, but hey, it's something you can do. Again, as long as you've been practicing everything else, the only thing that should be throwing you off is the setup. So just kind of keep that in mind. Again, multiply by the conjugate. This would be 3 root 2 minus 4. All you do is take both numbers and change the minus. Multiplying that out, that makes 30 root 2 minus 40, because remember, you got to multiply 10 by both. And then multiplying this out, 3 root 2 times 3 root 2, I might want to make sure I get that right. That is going to be 9 times 2, which is actually 18. Because again, 3 times 3, 9, root 2 times root 2 is 2, 9 times 2, 18. Here's the thing about conjugates. If I did this right, the middle terms cancel here, the middle terms cancel there, which means I don't really need to do the middle terms. I should do minus 16, because I know that this is going to cancel. Just for proof, that's negative 12 root 2, that's positive 12 root 2, so they're gone anyway. 18 minus 16 is 2. And so in the end, you look at this and you say, okay, all these can divide by 2. Again, outside numbers only, which makes this 15 root 2 minus 20, because that would be over 1. That's gone. So just make sure, again, that you're practicing. Make sure you're asking questions. It is important that you practice this process. Again, most of the mistakes that occur happen because you make a small error in the process due to inexperience. And I do understand, again, that you can do your calculator, you can do all kinds of other things, but again, you are going to hurt yourself if you continue to do that. And again, be sure to ask for assistance as needed so you don't get too far off track. Otherwise, again, things are going to get bad very quickly because you have to know this stuff. Talk to you later, and good luck.